Hi, my name is Vahan Davudyan. I'm a physics experimentalist for 30 years, and I have always inspired by nature, animals, insects, and plants. Well, in fact, these last 6 theories I'm going to do today, they're all about the insects, animals, and one of them is for the plants. And I have never seen these experiments in any book, in physics books at all. So I'm hoping these are unique so you can learn a lot. And then if you have a question, of course, this is my email, vahandavudyan@aol.com. You can email me or even you can call me. I will do my best. Even if it's beyond my expertise, I will research it and find it because I'm a great researcher and I won't give up. I have to find something and then I give up. So today I want to thank YouTube, which is amazing. They just provided this comprehensive, fantastic service so we can upload and then post our videos so people can watch. And they are doing a phenomenal job because that's beyond my comprehension what they do. That is so good, and you know, I can just upload my videos. Some other scientists or even ordinary people can do that. So we can learn, we can watch, we can see which one is good, and then we can even exchange views. We might be able to meet each other. So I just wanted to thank YouTube that is providing real good opportunity for me. As a matter of fact, I uploaded my theories like 3 months ago. In these last 3 months, I have more than 4,000 views, which is beyond my imagination. That's so good. That's more than enough I was expecting. Anyway, in fact, I call the YouTube synapse. This is in a human brain, and it's like a junction, and this amazing and billions of neurons are connected to these synapses, so they communicate from exactly like internet or huge network, and they communicate all together. So this is my analogy, and this is my comparison, that the YouTube is the synapse for us. He's connecting everyone. And in fact, when I see YouTube is doing such a good job, and then I appreciate that, of course, and then they provide this good service, and this is the way I think we can promote science. I mean, how could you promote the science if nobody knows you, if you are not lecturing, or if you're not talking to students, or if you're not posting your videos so people can watch? So this is the best way so we can watch those, YouTube movies, and then I can see it doesn't have to, you don't have to be scientist or physicist, you can be ordinary person, even an idea, good idea, put it online, and then people can watch it. And YouTube is doing this phenomenal job, and I really don't know how to thank them. And like I said, I will have 6 more theories today, but now these are not about the physics. Well, these are about the animals and insects and the plants. Well, of course, there's a lot of, aerodynamic, it's a lot of everything involved. Like the first one I did today was, I compared the aircraft aerodynamic to geese, because I lived in Westminster for 18 years, and we had a beautiful, fantastic outdoor life. But overall, everything I'm hoping will be posted today, so you guys can watch it. If you have any question, you can email me or even you can call me, and then I will find out exactly what you need and take care of it. Today is special because this is about the human ear. Let me just go ahead and post it, and I'll tell you, it's a little bit complicated, but I'm hoping you guys would love it, because this is so scientific. Let me see. Okay. Okay. So my theory today is gyroscope and inertia compared with humans' inner ear by Vahan Davudyan, physics experimentalist, and this is my email, vahandavudyan@aol.com. And in fact, because I've watched the universe all my life, and then I have a good library, a lot of books about space and physics and everything else. And I remember always I loved gyroscope. And imagine those old days, we had no gyroscope like 100 years ago, or maybe a little bit more, I would say, because Foucault did have one, yeah, more than 100 years ago. And the navigation was by, sun, moon, and the astronomical things, and then all they did, they used compass and then lighthouses. But nowadays, the lighthouse is not going to show you in ocean exactly where you are, and then you have to be able to do something more. And imagine those old days, the compass was huge help. Like, it came on 13th century, I think, by Chinese people, and that was a great help because at least we could tell where the south is, where the north is, approximately. But now gyroscope is amazing. Some spacecraft, they might have as much as 10. Why? That is because this device is amazing. It is keeping your orientation. And imagine, I did general relativity 2 weeks ago, and my main emphasis was you have to have frame of reference. When I say I walk 3 miles an hour, so it means that the earth or the surface of the earth is my reference. And imagine when you're in space, you have no frame of reference, and the gyroscope is an amazing device. Well, of course I will explain it. That disc is rotating so good. And it doesn't matter. The earth is not going to cause any torque whatsoever. It doesn't matter. Your airplane is going up, down, left, right, or getting tilted. It keeps its orientation. And then I remember I studied the natural science, and then I got with the highest grade in a high school diploma. And then I love natural science, especially the human body, animals and insects, and especially, laws of evolution. And then all of a sudden I remember the human ear is exactly like gyroscope. Imagine, we got 3 gimbals here. See, we have 3 rotors, and it doesn't matter how I orient this, always is keeping its orientation. And imagine we have here like 3 labyrinth in our inner ear, then exactly like this. Well, of course I have to explain. There is no way that we have a moving part in our ear, but that unique system I will explain in it is almost as good as gyroscope or even better. Because the human's inspiration can come from the human body, from the everything else. So anyway, I have to explain a little bit about the gyroscope, and then we can talk about the human ear, and then exactly what my analogy was. A gyroscope is a spinning wheel or a disc in which the axle is free to assume any orientation. So what that means that, the gravity is not going to cause any torque on it, so it's not going to change its orientation. Tops. When I was 6 years old, I was playing with tops. I had no idea what that was. At 10 years old, finally in high school, we learned tops was amazing. It's like a gyroscope. It's a simple gyroscope, tops. And then I remember we used to play with them hours and hours and hours. And then I was asking our science teacher, why it wobbles? I said, they don't call it wobble, they call it precess. I didn't know what the precess was at that time. And it says, as long as your top is spinning, the angular is a conservation of angular momentum. Your top is not going to fall. And that is an amazing idea. And imagine our Earth is like a top. Mars is like a top. Well, of course, they're not flat like top, but you know, they are doing the same concept. It's a conservation of angular momentum. Tops and front wheel of the bicycle, and you don't realize sometimes how important bicycle is, or gyroscope. Well, of course, these are some, technical terms. I apologize if I don't pronounce it good, because this is a difficult one. It's called equilibroception. And it's our sense of balance. Well, of course, I show you here. Balance is the result of number of body systems working together, the eyes, visual system, ears, vestibula they call it, with visual system to keep objects in focus. When head is moving, I compare the three semicircular canals to the gyroscope. It's a device for maintaining orientation in the spacecraft. So does the inner ear in human, which occurs in the vestibula, system. Inertia is playing important role. The small hair cell fluid causes the displacement of the top portion of the hair cells that are embedded in a jelly-like copula. Of course, the inner ear doesn't have rotating disc like gyroscope, but does the same function. Vestibula is a sense of balance. Sacula and cuticle are for the linear acceleration. Now I have to explain here exactly what I mean by this. And like I said, gyroscope is for measuring or maintaining orientation based on the principle of angular momentum. I remember when I saw this, that was a long time ago. Well, of course, I had to do, these are the old ones from 2000, and this is the one I just printed from my computer, which is more comprehensive. And you can see how this man is bending, and these are also, but he's a straight upright, they're not. So I compared these hair cells in a human ear that, I scale it up. I said, what if this hair cell is Vahan standing on a bus? Bus is accelerating, Vahan is going backward. Bus is decelerating, Vahan is going forward. Bus is going to the left, I'm going to the right. Bus is going to the right, I'm going to the left. So these hair cells are amazing. They can act exactly like my body. Well, of course, this is more complex than my body. But imagine, when the bus moves, what I have to do, I have to go forward, and then I have to grab something. This is exactly what happened. See, when you accelerate, they move. You can see here, they tilted a little bit. So it is keeping your orientation. Well, of course, there's no doubt this is part of it, and the most important part is the gravity. If I'm 80 kilograms, and then the Earth is pushing on me, is exactly 80 kilograms. As a matter of fact, like 2 weeks ago, I had to 2.5 hours my general relativity, which was work of almost 20 years, and the people loved it. In these 2 weeks, 1,000 people watched it. You know what? I'm assuming they loved it. Some even people, call me, email me. They loved it because I did not use any formula. So this is exactly like gravity. So the most important part in the gravity is my 80 kilogram. So the gravity is not playing any role. The determining value is my mass. Mass is dictating how much I want to accelerate. So if I'm like 40 kilograms, I will be accelerated 40 kilograms. That's why, I get the opposite, exactly 40 kilograms. So they take care of it. And this is the human ear. Well, of course, it's not real good. And this part, you can see, is called vestibula. And I apologize if I don't know how to pronounce. These terms are difficult for me. And in fact, this is the sense of balance. And these two are so important. And I remember I was in Disneyland, and then I studied this, and that was the best day of my life. Because before this, I was thinking that, when you feel the acceleration is because your blood is rushing to your brain and your blood is displacing, and then I realized I was wrong. So this is the way they are. This part is the sense of, and then uticle and succule or succula, I think, these are responsible for measuring linear acceleration. And imagine how precise this system is. I mean, how good it works is beyond my imagination. I mean, how could you tell you're accelerating, decelerating? Well, when I was in high school, I remember we talked to so many people, and they were spinning so fast. And then our, physics teacher, not physics teacher, I mean, science teacher said, guys, I have to explain to you, whenever you're disoriented and then you're rotating so fast, it's because these things are displaced. We didn't understand that at all. You know what he said? He simplified. He said there is a jelly in your ear and it's getting pressed. But now this is more scientific, and in fact even the doctors or everyone else is talking about these cells. So you can see there's a jelly here, they pushed on it. Well, of course, it's so complicated, but I don't know how the signal is getting to your brain. How does your signal know you're accelerating less or more? But this picture shows perfect. Imagine. This man is standing upright. See, those cells are upright. So practically, if I cut this, it'll be my boss. He's standing in boss. And then he's not holding any rate. So when it goes forward, he's going to go backward. When it goes backward, he's going to go forward. But this man is what? He's bending. But you can see that tells that, you bend. I remember some people say, when I get up in the morning, I don't have to jump because sometimes I get disoriented or dizzy. And that's exactly what happened. Because I think there's a delay here, and I have no idea. I'm not a, expert. I don't know. There's a delay here. You should be able, when to get up your bed easy, so you won't get disoriented. Anyway. And in fact, like I said, top is a gyroscope, bike is a gyroscope. Well, of course, every little thing we can learn in laws of physics, you have to simplify. I mean, how could you learn gyroscope without knowing the tops? You know how important this tops is? This is one of the most important simple things in laws of physics. You spin it like this, it's a conservation of momentum. And guess what? Some tops go like 2 minutes. And as long as they're rotating, what happened? They don't fall. And then I compared with Earth, and Dr. George Gamow in Denver said one time something amazing. He had so many books. He was professor for 20 years in Denver. Then he said, Earth is a gyroscope. But who's the spinning Earth? We're not spinning. It's just called, it has the angular momentum. And then I realized that the Earth is not like top. Well, you can compare to the top, but it takes 26 years because Earth is a planet. It's not a toy like this, and it takes 26,000 years to precess. Precess, well, it's almost like a wobble, so that's the way it is, and then after a while, it just orients itself. But because this is so small, it's under the influence of the gravity, finally it falls. And then when I was in high school, I did some experiment. One part of the top was 1 centimeter. That was a sharp nail. And the other part was almost like 3. I remember I used to go from the bottom like this. It would rotate almost 1/3 of this way because, see, it is not close to the center of the Earth. And imagine that 4 centimeters is playing a role. But this one was 1 centimeter. It was closer to the center of the Earth. So this one would wobble and precess a lot, and it wouldn't even last like 30 seconds. This would last like 3 minutes. So anyway, this is the gyroscope. And like I said, those old days, you know, we would travel with the, compass, with the lighthouses, and then the compass was around like 13th century and saved humans' life a lot. And then I think, if I'm not mistaken, the Chinese people came with the idea, and then the lodestone was discovered. And then they realized, you know what, you can sense the, north and south. Well, of course, it was not big deal because animals know about that millions of years. A few minutes ago, I did one experiment for the birds, and then I told the humans had no idea the birds been around for millions of years. They had like airfoil, like airplane. Why for us took many years, and after 100 years we discovered, you know, Wright brothers, they came up with the idea, and the airfoil was one of the greatest things that was discovered. Then his name was Daniel Bernoulli. He discovered that the airplane is like a, you know, bird is an airfoil. So anyway, this is the gyroscope. And like I said, it's for the measuring, responsible for measuring or maintaining orientation. And imagine your airplane. Let me show here so you can understand exactly what I mean. This is the airplane I did. So of course I had to demonstrate this for the laws of aerodynamics. And you see what I did. I had an amazing device here. I had ball bearing in a ball bearing. So one of them goes 180 degrees and the other one 360, because I used the same concept in Regis University and the professor loved that. That's my invention. Because if it's just one direction like this, pendulum is going to stop because of friction. But you know, it goes like this, at the same time it goes like this, and it can go almost to 360 degrees. Well, of course, mine was small, 150 grams, it went only 165 degrees, which was more than enough. But what I mean, see, this is the orientation, and imagine we are in a space, we don't have any frame of reference whatsoever. It's blue sky, or not even blue. We have no idea where we are. See, airplane is going like that, the gyroscope is going like this. Airplane is going like that, gyroscope. It's exactly like, you know, it doesn't matter how you do it. You put one ruler, I would say the most sensitive ruler, we can, you know, measure, micrograms or even less on a short thing. And imagine, it doesn't matter how you move the one side, the ruler, and the other one is going to be affected. But if there's a device here, it can change everything. That's exactly what happened. The airplane goes like that, gyroscope goes like this. Airplane goes like that, like that. So you can see in all the cases, the orientation is kept. And poor pilot has no idea where he is. You know, according to the gyroscope, they can maintain everything. And I remember Apollo 11, God knows how many books I read, that was the main concern. They had to, every time, I remember from 1960s all the way till 1974, I think, which they stopped it. They had to add more gyroscope. Because imagine the engineering is just a lot now. I mean, technology has gone way beyond our imagination. Anyway, this is another thing, is showing the top. You can see precision of a spinning top. The spin axis traces surface of a cone Earth. Its gyration takes 26,000 years. So imagine my top is not like that, it's a more flat. But imagine it goes like this all the way here and then like this. And finally, the friction. Well, of course, if you want to do top, you have to do it in vacuum. But still it's going to stop. Because see, this part has, let me see where the, yeah, that part has friction. It doesn't matter how so sharp it is, and finally it's going to stop. And I'm hoping I have 3 more for the plants and insects. And then I will upload everything today, and like I said, I am so happy that YouTube provided this. And last but not least, I have to mention some people, you know, in YouTube, which, you know, they're my favorite scientists. One of them is Dr. Michio Kaku, which is amazing scientist, and then he's been around so many years, and then I watch his programs all the time. And I have read his book since 2005, 2006. And the most important one was teleportation and Are We Alone? And the way he explains is so concise, is so coherent and logical. And I do understand. There's another scientist called Dr. Nick Lucid. He is so enthusiastic, I love him. And then he explains to the best of his ability. I like the way he explained. There's another one, his name was Dr. Derek Euler. He is so good. His precision is beyond my expectation. And then there's another one, which I love her. Her name is Dr. Diana Cowan, the physiker. She is so good. I mean, she has a great knowledge of everything. Almost everything she can explain. And there's another person, I like him, his name is Dr. Arvin Ash. He's good also. And there's another young man, he calls himself Professor, and I think his name is Dave because that's his first name, Professor Dave. And then I learned a lot from the laws of thermodynamics because his explanation is so good, and like I said, is concise, coherent, and logical. And I'm hoping, the reason why I bring up those names, because, you know, I like to get in touch with them. And in fact, I did mention this like a month ago and nobody called me. And, you know, they have my email anyway. And, you know, I'd be happy to get in touch with them. And I think my main idea is 30 years in physics. This is the way you learn laws of physics. This is the way you learn science. If I don't exchange views with Dr. Michio Kaku, I never learn. Well, of course, they're much more educated than I am. But, you know, even some people like me, which, you know, self-educated in physics, but electronic expert, it doesn't matter. Albert Einstein was failure. He was self-educated almost. And then, like Leon Foucault was self-educated. He did something amazing nobody had done in the history of science. The Foucault's pendulum changed the world. So I'm hoping this scientist can get in touch with me. We can exchange views, and then we can learn. And I want to thank all the people who are watching. And like I said, anytime you have any concerns or anytime you have any questions, you could just call me, or like I said, this is my email, vahandavudyan@aol.com. By the way, I also have a site. It's called GoDaddy. And then if you go vahandavudyan@aol.com, that site coming, and you know, some of them are so good. And amazing thing about this site is, it is not like video. They put my photocopies, which I did in 2002 or 2003. They put the photocopies on a printer, on a computer, so you can even read the photocopies. At the same time, you can read the videos. And you know, I like to thank Kinko's. They did that for me because that was a new technology. So it's called GoDaddy. So it's vahandavudyan.com at the GoDaddy. And thank you for watching, and I'm hoping I can hear about you guys so fast, because in electronics we had something extremely important. It says that the vibration will not sustain. What that means that if there is no feedback, the vibration will stop. My best example is the tank circuit. Because we have capacitor, we have inductor. And I don't know who discovered that circuit, but it's amazing. You know, capacitor can be discharged, charged. The inductor can be discharged, magnetic field, back and forth and back and forth. They create electromagnetic waves. Well, of course, even in a subatomic parts, it's exactly like focused pendulum, which is harmonic oscillator, mechanical oscillator. The friction in the stopper. And amazingly, in even subatomic particles like electrons, neutrons, and protons, we have friction because they bump to each other, you know, they get kinetic energy, and finally they die. And then I remember when I was in Orthrop, we came up with this idea: if you have a transistor, which is the fastest switch in the world, you can put that transistor and it will go on and off, on and off, on and off. So you will have the oscillation. But there's a point here. Laws of thermodynamics come in an equation. For that oscillation, you need a battery, you need energy. So it doesn't matter, you never get free energy. So I'm hoping you guys learn a lot, and thanks a lot for watching and appreciate it.